Hi there, this is episode 2 in our whiteboard tutorial series on multi-digit multiplying. The second problem is going to involve 2 digits times 2 digits. If you wanted something times just one digit, like 2 or 3 digits times a one-digit number, you want another tutorial that we did earlier. This one is going to be 46 times 35. We're going to talk about 4 different ways. First, we're going to talk about these three: the box method, the partial products, and the standard algorithm. And I'm going to try and talk about each one as treating the number 46 as two numbers, 40 and 6. And the number 35 as two numbers, 30 and 5. And I'm going to try and show that each of the methods we're using is going to take apart these numbers into their two place value parts, a 40 and a 6, and multiply those by each part in the other number. So the 6 is going to be multiplied by 5. 6 is also going to be multiplied by the 30, and the 40 is going to be multiplied by the 5, and then the 40 is going to be multiplied by the 30. That's going to happen in all three methods on this page. Let's start out with the box method. The box method takes 40 and 6, so it takes 46, and it multiplies it by 35 by splitting it up into its two simpler parts, and then giving each number a space to write the partial product in that we talked about before. So you can see over here, the 5 being multiplied by the 6, its answer goes here. 5 times 6 is 30. When the 6 is then multiplied by 30, that's like 6 times 3, but 10 times bigger. So 6 times 3 is 18. 10 times bigger is, adding that other 0 there, 180. The 40 needed to be multiplied by the 5, and that happens right here. 40 times 5, 4 times 5 is 20, and 40 is 10 times bigger than 4, so the answer is 10 times bigger. Add a 0 for every 0 that's in the multiplication that you do. And 30 times 40 is like 3 times 4, but with 2 zeros extra in the problem, we're going to have 2 zeros in the answer. You take these 4 partial products and you add them together. 1200 is going to be added to 200. I like to take them largest to smallest. 180. Oh, big thick marker tip. It's going to be tough to see after a while. And 30. We're going to add these all together. We've got them all right. 1200, 200, 180, and 30. And just before we get to a final answer, I want to just say I'm pretty sure that when I estimate 40 times basically 30, a little more than 40 times a little more than 30, I'm going to get a little more than 1200. But it's not quite 50 times 40, so it's going to be between 1200 and 2000. If our answer is outside that range, we've done something wrong. So let's see, when we add these together, we're going to get, I'm going to try and give us some room here. Whoop. We're going to get, let's see here, 11. 1, 2, 2, 4, 6. And we're going to get 1610. 1610 as our answer. All right, that's the box method. It takes 40 and 6, splits it up into their two parts, multiplies those parts by each other, adds it back up at the end. Now, we're going to do the partial products method, and we are still going to keep treating 46 as 40 and 6. When we multiply it by 35, we're going to keep treating 35 as 30 and 5. And we're going to multiply both parts of 46 by both parts of 35. We're going to keep track of the work a little differently. When we get 6 times 5, get 30, we're going to write it on its own row. 40 times 5 is 20, plus an extra 0. That gets its own row. Hey, look, we just did the same work as in the box method. We've now we've done everything we need to do with that 5. Now we're going to deal with the 30. 6 times 30, remember this is a 30, is 180. And 40 times 30 is 12 with 2 zeros, 1200. We're going to add those all up together, and we're going to get 0, 1. Carry the 1 for the 11, and we're going to get 6 and 1. Hey, 16,110. We like that because it's the same answer that we got over here, and it fits with our estimate. Our estimate was that the number would be somewhere between 1,200 and 2,000. In the standard algorithm, we're going to do the same. We're going to make sure we multiply the 40 and the 6 by the 30 and by the 5, but we're going to combine some of these rows. So when we multiply the 6 times the 5 and we get 30, we are going to deal with this extra 3 in the tens place by putting it in the tens place over here and reminding ourselves to add it when we're done multiplying the 4 and the 5. The 4 is a 40, but we're going to multiply it as a 4 times 5, and we're going to get 20 plus that 3. You can see here we've just added the 30 and the 200 onto the same row. We've kept track of that by carrying the 3 from the 6 times 5 equals 30. We carry the 3 into the tens column, and we added it in at the end of our 40 times 5 multiplication. Now we're done with our 5, so we basically have nothing here. Although this is a 30, so some people like to say we have a 0 there. So they say, hey, there's a 0 there. Everything we multiply the 3 by is actually multiplied by 30, so they put a 0 here as a placeholder. And I like to think of it as a reminder that this is 30. So 6 times 3 is 18. When we write the 8 here, we're carrying over an extra 1 to add. We can forget about this 3 because that was from before when we were multiplying by that 5. We carry this 1 over here so that when we're done multiplying the 4 times 3 and we get 12, we're going to say, wait, we had a leftover larger value. That 100 was left over. Let's add it in to the 1200 we just got. Let's add it to the 12. So we do 4 times 3 is 12, plus 1 is 13, and we get that. And if you'll look closely, I'm pretty sure that's these two columns, but organized into one place by kind of carrying as we go, adding them up, these two rows up as we go. That work is hidden a little bit, but it does happen. We're going to carry the 1, 6, 1, and boom. There we go. We got our 1,610 each way. You can see that the box method organizes that partial product, each partial product in its own box and then adds them up. This organizes each partial product in its own row and then adds them up. And the standard algorithm really just does some of the adding of place values as it goes, and kind of hides it in carrying the 1 over and adding to the multiplication after it's done. A fourth way that I have not mentioned yet does all three of these, does similar things to all three of these, and it does it in a tight space.